Okay, so we are live.
Hmm.
Share my screen. Okay, so our Leetcode's POTD of the day is elements appearing more than 25% in a sorted array. So let me explain to you. For example, we have an array given 1, 2, 2, 4 times 6, 7 and 10. So what's 25%? It is ARR dot which means that total length of the array divided by 4 times if an element appears, that's a 25% times. So if we check the array, in this array we have 5 elements. 1 appears 1 times, 2 appears 2 times, 6 appears 4 times, and 7 appears 1 time, and 10 appears 1 time. So as we can see that, and only 6 is an element that meets the condition of appearing more than 25% time, so it is our answer. So how we can approach this question is, we can use an another map to store our frequency of our array elements, that how many times an element appears in the array. After that we can again traverse that array and check if it appears more than 25% time. If e dot second greater than error dot size divided by 4, then we can just simply hit e dot first. So let's try running it. Okay, I think so we need to hit on equal. So as you can see that, let's try submitting it. So yeah guys, it got submitted. So now over to you, Sangam.
Okay. So where's the question that we have been asked today in today's GFG PUDT is that there is an array that is given to us, and there is an element should be maximum. Like we have to find the sub array whose size is equals to k and whose sum is maximum in all of the sub arrays that are available in our the subarray of length which is equals to 2 whose sum is maximum. So if we considered length equals to 2, so these are the subarray that we can form. First one will be 100 200, second one will be 200 300, which we have written here, and then will be 300 and 400. And among these subarrays we have to find the sum of them, and the one with the maximum sum will be returned. So in this case the sum here coming out to be 300. In this case the sum is coming out to be 500, and in this case the sum is coming out to be 700. So among these sub arrays whose size is equals to k, we have to return the maximum sum. So here in this case it is 700. So we are simply going to return 700 as our answer. Now here is another thing that we have to consider. If we go down below this question, we are going to find out that the time complexity that they are asking us to do is in O of n, that is, it should be linear, and the space complexity should be constant, that we are not taking any kind of extra space, we are not storing element in any kind of array, map, or vector, or any kind of these data structures, because it is going to take extra space. So we have to deal with whatever we have been given here, and along with that, the time complexity should be O of 1. So let's just understand that how we are actually going to solve this problem. See, the technique that we are going to apply here to solve this problem would be sliding window. Okay, so what I'm going to do in that case is, like, this is the subarray that we have been given: 100, 200, 300, and 400. Yeah, and the size that is given to us here is 2. So I'm going to take two elements. First one will be my I, the second one will be my j. Okay, and this will be my sum, which is going to store the sum up to each indexes in I and j. So initially I would be at I, and the value that is at I is 100. So I'm simply going to add 100 to my sum. So sum plus 100, and my sum will eventually here become 100. Yeah. Then I'm going to check that if this 100 is maximum or not. So here is another variable that I'm going to take, which will be answer. And initially the value of answer would be 0. What I'm going to do after that is answer would be is equals to, I am going to take the maximum value among these two variables. First one will be sum, and the second one will be answer. Okay, so this is the thing that I'm going to do. So let's just do a dry run now in this case. First will be I, here we are going to write j, and here will be our sum, and here will be our answer. Okay, initially they both are at 0, 0, 0, 0. Yeah, and here would be my size, which is k. Now I will tell you why we are taking count here. Yeah, I will tell you. So initially I am at index I, and here the value is 100. So I am simply going to say that I am at I am 100. J is also 0, and S would become here 100. And if you compare the values of 0 and 100, 100 is maximum, so answer would become maximum. And after I do this traversal, after these things are done, I will increment my value of I to another variable, and I will simply increment the count to 1. Okay, so just simply doing is what, just incrementing the value of count by 1. Okay, so now my I is at this level. Okay, so again we are going to do the same thing. I is my at 1, j is 0, sum would become 300. If we compare the value of 100 and 300, 300 is maximum. So therefore our answer will eventually become 300. And count, as I already told you, as we are going to increment it, we are simply going to increase the value of count. So here I have incremented the value of count, and it is coming out to be 2. Now here comes the role of count. Here I am going to see that how we are actually going to use the value of count. So after this, yeah, in my while loop I'm going to keep moving forward, and here I become this. Yeah, so I will become 2, count will become, j will become stay 0, and the value of I, when will be added to the sum, it will eventually become 600. And if we compare the value of answer and 300 and 600, the answer would be 600, because that is the maximum value. And here our count will become 3. Yeah, now here we are going to apply a condition. We are going to apply a condition that while count is greater than k, what you should do is you should decrement the value of sum is equals to decrement the value of element that is available at j, and simply increment the value of j. So what is going to happen in this case is, right now my count is what? My count is 3, and the given k value is what? 2. So this condition is validating in this case. Okay, so whenever this thing happen, right now my sum is what? 600. I am saying from the my sum, simply subtract the value of the index that is available at j. So here I am subtracting it, and the value that was there was 100. So we will get what, 500 here. Yeah. And after this, simply decrement the value of count. Yeah. So after I do this thing, j will come here. So j will be now my here, and my count will eventually come down to 2. My sum will come down to 500. Maximum will remain 600. I will remain same, but j will become 1. Now if you see carefully, first of all we were including all these three elements, 3, 2, 1. So it will eventually coming out to be 600. Okay. But if we consider the subarray, which is this one, this subarray sum is what, 500. So if you see carefully, by using this approach, we are decreasing the size of the subarray. We are decreasing the size of the subarray so that it fits in our zone of k. So now the overall thing that we are doing is, this is our, let's say, size. Yeah, and this is my k. I'm going to keep moving forward, keep moving forward, keep moving forward until my this length is smaller than k. Okay, if this length become greater than k, what I'm going to do, I am simply going to erase this element. 1 minute, let me just draw it again here. So these is, and this one, yeah. So I am simply going to remove this element, and I am simply going to decrement my array length to just this part so that it satisfies the conditions. This part I am actually simply removing it. So as I now move forward, again it is coming out to be 3 part. So now I'm simply going to remove this thing and only going to consider this part. Again as I move forward, again the length will become 3. So I'm going to simply remove this thing and take only this length into consideration. So that is how my sliding window is working. We have been given a array. We are first of all going to consider all the elements till the value k. Once the value becomes bigger, we are simply going to delete the first part and only consider this part. Again we are going to increment the value, so it will become this. And if this value is coming out to be greater than k, then I'm simply going to remove this part and only consider this part. And I'm going to keep moving forward that way till I reach the end of the sub array. And that is what we are doing via this code here. This code is helping us to delete this part. Just do not consider this, because eventually the sum was coming out to be 100, 200 and 300. Till this part the sum was what, 600. But if I remove this part, the sum was coming out to be 500, which is what we are getting in this case. Yeah. And then again I'm going to keep moving forward, so it will be 4. And again the same approach will be applied in this case, and at the end I will get the maximum value as my answer. And if you see carefully, the thing that I'm doing here is I am taking a while loop which will run till n. Okay, and my second loop is not running till n, it is just running till the value of k, and k will always be less than n. So eventually the overall time complexity of my code in this case is O of n, which is linear. And as well as I am not taking any extra space other than these variables. These are the variables that I am considering. Nothing other than that. There are no DSC. No DSA is used. No data structure other than the given one are used. So therefore the overall space complexity will be O of constant. Of there was a way of nested loop, but eventually it will require us to use two loops. So first loop will this one, second loop will this one, and overall the time complexity will come out to be O of n square, which is what we don't want. In this case we want O of n constant. So I hope that I would be able to make you guys clear this topic out a little more, and let's just see what is the code would look like. So what we have done in this case is we have taken a variable name count, which will calculate the count. Then we have taken a variable name answer, which will be our answer that we are going to return here. Then we are taking two pointers. First will be I, second will be j. These are the pointers that are going to act like the elements that we use in our for loop. And then there is a long variable sum. This will only calculate the count. Now here what I'm going to do is I'm going to apply a for loop which will run till 1 till the size of the array. Okay, and simply adding the element to my array and simply increment the value of count to just determine that I am moving forward. So I consider this element, so I increment the value of count, it will become 1. I move here, I consider this element, increment the value of count, it will become 2, and so on and so forth. So that is what I'm doing. Now once my size of count becomes greater than k, that is I am now considering a size, considering element 1, 2, 3. K size was what? 2. So once I consider, until this the count will become 2, but once I reach the here, once my value of count, once my array size becomes greater than k, do what? Decrement the first element and simply decrement the count and increase the j. So what I'm doing is just remove this element and only consider these two elements. So thus my size will become 2. That is what I am doing in this approach. Once I find a size which is greater than k, I am going to simply remove the first part, first few elements from my sub array. And via this way, I am going to simply maintain the window. And after that, if the value of count is equals to k, it just simply means if the size of the array is equals to the size of k that is given to us, find the sum which will be the maximum of maximum and answer, and eventually increment the value of I, so that we are going to end eventually to our loop. And finally, after this loop is done, simply return our answer that is there. So let's just submit this code out. As you can see, it is working in test cases, and now we are submitting it. So you can see it is working perfectly fine. With that, guys, today we have solved both GFG and Leetcode PODT. I hope that you guys be able to understand it and be able to solve the problem. With that, over to you, Shivam.
So yeah guys, thanks for joining us. We will catch you up tomorrow.
Yeah,
Okay
guys.
guys.